Okay, this video will cover how to name ionic compounds. Hopefully you've already watched the video about writing the formulas of the ionic compounds. So we have binary ionic compounds involving only two elements, and then we have polyatomic ionic compounds. It's important that you count the number of elements in the compound because that will give you a clue as to the naming. So the fact that these compounds are ionic, you'll recognize because you have a metal and a nonmetal. So think of your periodic table, have one in front of you as you're working, and the metals are on the left side of the staircase, nonmetals are on the right. And binary means that you're going to see two elements only. So have a look through these first few examples. Every time there's a capital letter, there's a new element. So one element, a second element. One element, a second element. So 1, 2. Magnesium and nitrogen, that's 2. Lithium and oxygen. Iron and chlorine. Tin and oxygen. Silver and chlorine, and so on. If I just bump this up for a second so you can see these other examples, here we have aluminum, carbon, and oxygen. Lithium, nitrogen, and oxygen. Count the capital letters. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4. So these are polyatomic ionic compounds. So it's important that you count the number of elements in the formula so that you can start, so that you'll recognize the naming pattern. Okay, so the naming pattern is shown on the right here. There's going to be two words. The name of the metal for an atom or an ion of sodium, we still call it sodium. So the name of the metal is the first word. And then there may be a Roman numeral that we'll put in brackets. That's if the metal is multivalent. And then there'll be the name of the nonmetal, but we're going to change the ending to IDE. So you have an IDE ending on the nonmetal for binary compounds, when there are two elements. So to look at example 1, we think of the symbol. Well, first we'll just check. Look at your periodic table. Do you find sodium on the left side of the staircase and bromine on the right? That means it's an ionic compound. So that means you follow this format. The name of Na is sodium. Is sodium multivalent? No, it's in group 1, not the highlighted, not the transition area or transition metals or tin or lead. And then we look at the nonmetal, except instead of bromine, bromide, so bromide. Okay, number 2, the name of Ca. Calcium. Is calcium multivalent? No, it's not, and not in group 2. It is in group 2, and those metals are not multivalent, and so we move on to the name of sulfur, except we drop the UR and add IDE. Moving on to number 3. Metal-nonmetal combination, it's ionic. There's two elements, so we name the metal magnesium, and then the nonmetal nitrogen becomes nitride. So try number 4. Okay, hopefully you came up with lithium oxide. Now, 5 and 6 are a little trickier because iron and tin, showing up in 5 and 6 here, are both multivalent metals. So we see the Fe and we name it as iron. Actually, I'm going to move that down a line. We'll leave space for the Roman numeral that we're going to need to put, and then Cl we name chlorine but change the ending to IDE, just like before. Okay, and so we now need to figure out the Roman numeral. So this is my suggestion to you. There are a few different ways to do it, but here's my suggestion to you. Fill in a 1 if it was omitted in the name, and uncross those numbers. So bring them back up. So the 2 comes back up top, and because it's the first ion, it would be positive. And the 1 goes back up here and becomes a negative 1. So uncross and then check. Check your periodic table. Does the chloride ion have a negative 1 charge? If it does, then the charge that you have for that iron is correct. And so this is iron 2 chloride. Now let's try number 6. Again, fill in any subscripts of 1 that have been omitted and uncross. So we end up with a positive 1 there and negative 1. So I've uncrossed, brought these numbers back up here. Now, check your periodic table. Does the oxide ion have a charge of negative 1? And you'll find out that actually, no, it doesn't. The charge of the oxide ion is negative 2. So what do we have to do to the negative 1 by multiplication in order to make it the correct charge? You'll find we have to double it. Negative 1 times 2 will be negative 2. And what do we have to do then to the positive 1? We also have to double it. So whatever you do to the negative ion in order to make the charge correct, that's what you have to do to the positive ion. And that will then give you the correct charge on the metal. So tin 2 oxide. Now, so to show you another way to solve this problem, I'll just recopy that FeCl2. And this time, a different method to get the same Roman numeral. Fill in the 1, and then look at your periodic table and see the charge of the chloride ion and fill in that negative 1 charge. Call the charge of the metal X, because we don't know it yet, and set up an equation where you take the subscript and multiply by the number up top, in this case X. So 1 times X plus 2 times negative 1. And we set that equal to 0 because this entire formula that I wrote in blue to begin with is neutral. So 1 times X plus 2 times negative 1 equals 0. Then go ahead and solve for X. X minus 2 equals 0, so X equals 2. There's your Roman numeral. It works for this other one also. So we had SNO. So go ahead and fill in the 1s. Fill in the charge of the oxide ion that you know it should be. Call the other one X. And now 1 times X plus 1 times negative 2 equals 0. And so X minus 2 equals 0. And we finish with X equals 2. And again, there's our Roman numeral of 2. So you can either uncross, check the negative ion charge. If it's not correct, fix it and do the same thing to the metal charge, or you can set up an algebraic equation and solve. Okay, you'll get more practice as you do worksheets. Number 7 and 8 I put in here just to remind you, just to trigger your memory. Remember that silver and zinc are in the transition metals, but they do not have a Roman numeral in their names. And that's because silver is always positive 1. So it would be wrong to write silver 1 chloride. All we need to write is silver chloride. And that's because silver is always a positive 1 ion in an ionic compound. It never has any other charge. The reason that we had iron 2 chloride was that in a different compound it might have been iron 3 chloride. Iron has a couple of different charges. So to finish this up, we'll have zinc fluoride. Watch your spelling of fluoride. It's a UO. Okay, moving on then to polyatomic ionic compounds. Really, it's everything I've just shown you, with the idea that the second word is going to come from the polyatomic ion list on the back of your periodic table. So let's try example number 9. Al is aluminum. Remember, we used brackets for the polyatomic ions. Always look inside the brackets for the name. So find the CO3 ion. You'll see it has a charge of negative 2 on your table. And you'll see the name of that is carbonate. So that compound is aluminum carbonate. Just to show you, it's being made of this aluminum ion and the carbonate ion. If you cross those charges down, you will reform the formula that I gave you in blue here. The instructions were to name it. So we just need to name the ions that make up the compound, aluminum carbonate. Try number 10. This compound is coming from potassium and NO2. What's the charge on NO2? Negative 1. Now, it might have been hard for you to see the polyatomic ion there, but the clue should be that there's 3 capital letters. Remember counting the capital letters in the beginning? Well, when you have 3 or more, there's definitely a polyatomic ion involved. if you don't see brackets, you can open them after the metal and close it at the end. And there's really one nitrite and one potassium here. So potassium's not multivalent, so we don't need to actually figure out the Roman numeral, and so we just have potassium nitrite. So continue with 11 and 12, 13 and 14, and then check back with the video. Okay, so continuing, you'll see we have lithium nitrate, sodium bicarbonate, magnesium hydroxide, calcium, careful here, keep looking inside the brackets for the name of the polyatomic ion, calcium hypochlorite, calcium chlorite, calcium chlorate, and a few more to finish. Try these and then check back with the video. Okay, so we have calcium perchlorate, calcium sulfite. There's the sulfite atoms, or atoms that make up the sulfite ion there. Okay, 19. Notice I have iron here. Iron is multivalent, so we are going to need a Roman numeral here. We have iron something nitrate. So to do the algebra, well, I guess I'll start with the uncrossing. We fill in the 1, uncross, get a -1, uncross the 2, get a +2. Check your table. Is nitrate, check the list on your back of your periodic table. Is nitrate -1? Yes, it is. Then that means that the iron charge is +2. So we write a Roman numeral of 2. Now, if you wanted to do the algebra, Fe bracket, NO3 bracket 2, and I would fill in my 1 here, fill in the charge that I know to be correct for the nitrate ion, call this X, and just be careful to use the numbers outside the brackets. So 1 times X plus 2 times -1 equals 0. So X minus 2 equals 0, X equals 2. Now number 20 is a little bit tougher because the brackets aren't there, and people sometimes make a mistake using a number that's a subscript in the actual polyatomic ion. So be careful to put brackets in there so that you stick a 1 outside the brackets. So now if you go to uncross, you'll uncross a 1 and get -1, you'll uncross a 1 and get +1. Then you check and see if carbonate is -1, and you discover, oops, no it's not. I have to double that to get the carbonate charge of -2, which means I have to double this to get the correct charge of the copper. And so this is copper 2 carbonate. If you had done the algebra, CuCO3, you would have had your brackets go in and a 1 at the end. So it would be 1 times X plus 1 times the charge of the carbonate, which is -2, and that equals 0. So X minus 2 equals 0, X would equal 2, there's our 2. Okay, trying number 21. Again, you don't see the brackets, put them back in. Yes, copper is multivalent, so we're going to need a Roman numeral. The name of that PO4 -3 ion is phosphate. So you could uncross or try the algebra. Uncross, we get +1 and -3, and phosphate is -3, and therefore copper 1 phosphate. Okay, last one here. Lead, and lead is multivalent, and the name of ClO2 -1 is chlorite. And if we fill in our 1 here and uncross, we check on the charge on the chlorite, it is -1, therefore the lead is a charge of +2. And we finish with lead 2 chlorite. Okay, so we've done 22 examples here of naming ionic compounds. What's common to all of these compounds is that they have a metal and then a nonmetal. Sometimes the nonmetal is a single atom ion, like in the beginning with sulfide and nitride and chloride, and other times it's a polyatomic ion, like we have here at the end. So look at that list of polyatomic ions so that and refer to it often, When you see 3 or more capital letters in the formula, starting with a metal, then you know you definitely need one of those polyatomic ions from the list for the name. So go ahead and look it up. If there are no brackets in the original polyatomic formula, then go back and put the brackets in so that helps you recognize the ion. If the metal's multivalent, make sure to solve for that Roman numeral, either setting up an algebraic equation or doing the uncross method and checking your negative charge. Okay, so good luck with your practice. The more you practice, the better you will get at this. Bring your questions in.